Hey there, we're at MilAM TV here in Tampa, and I have the pleasure of talking with Justin from REM Surface Engineering. Um, I think I don't know how many of these I've seen you at, Justin, as the CEO there. You're everywhere. Everyone knows you. I love walking by your booth and seeing the beautiful parts that you're able to create. And so I'm excited for our conversation today because you guys are a critical part of the AM supply chain. And a lot of folks in the past used to forget about post-processing. They used to forget about the surface finishes. No, it's perfect. Take it off the build plate and there it is. And well, I think we know. No, that's not good for everything, right? So can you talk to me about how you have seen additive scaling in your business and the kinds of industries that you are serving today?
Yeah, absolutely, and thank you for having me. Happy to be here. So scaling has been interesting. So we've been in additive now for a little over 15 years, so quite a while, and we've certainly seen a lot of evolution in the industry. A lot of good development. I think we're certainly moving in the right direction. I would say scaling it's gone through a couple different phases. I think there was the early work was a lot of additive just kind of trying to prove itself a little bit, right?
Oh,
It
yeah.
was new, it was different. People didn't necessarily trust it. We would get jokes after we would polish a part. Sometimes they'd be like, "Oh, it is real metal." It's like, of course it was,
Yes,
right?
it's real metal.
It just looked different. So, and then I think as you kind of go forward, you think about there's sort of two sides for us. And I think for a lot of people, there's the sort of the government scaling side, and then there's the commercial. Commercial has been, I think, kind of methodical, barring a few of those really key applications that really hit it out of the park. But we see a lot of really good momentum there. We see a lot of the aerospace primes gaining momentum, doing more there, really leveraging additive in the right ways. For the applications where it really makes sense. On the government side, we've been really fortunate. Over the past 8 years, we've had a lot of cyber contracts that we've made use of. I'd like to think very effectively, developing new technologies that we then were able to take to the commercial space as well. And it's been beneficial. It's helped us, I think, develop credibility, really valuable data sets that back up the claims that we would make in terms of performance improvements and other capabilities in terms of being able to get a part to meet specs that are present in legacy. The problem that we're kind of bumping into these days on that side of the game is that we've developed these advocates. We've shown that we can do what we can say we can do.
Yep.
And all these folks that have these programs and are controlling these different sustainment requirements, and they don't have any money now to go forward, right? We're a company where we offer a service, we also install, and ultimately my perspective is like we should be on these depots so that we can support the printers right there at point of use and get these parts ready to go and back out to support our war fighters or however we can.
So you want to be at the depot level, right in there with the right equipment, getting these parts to be properly processed and with the right surface finish to last and be properly installed. And you're finding what is happening in the acquisition process.
Basically, there's no, as I understand it, and I will admit to being not massively versed in this, there's not really a vehicle to get money to these people, right?
Yeah.
Like the money that you need for this sort of capital equipment, there's no specific route to get it there. And we're not talking about tens of millions of dollars, but we're talking about you need to put some money to these infrastructures to be able to really actualize this tool that is additive manufacturing.
Okay, so the model is to get them the equipment and then train them to use it.
Absolutely.
Is there we just spoke with Penn United right before you, and they talked about a slightly different approach where they would situate, well, this is for commercial mostly, commercial sector, where they would situate the piece of equipment on their shop floor and operate it on behalf of.
Sure.
So obviously that's different, and that works very well with commercial, but with government it's completely different.
Well, and I think it's a part of the puzzle as well. I think,
Yeah.
so there's different companies in the surface finishing world, they have their different business models. We're pretty agnostic in that regard. Like we're happy to do outsource processing support, and we've done that.
Yeah.
Like we've had dedicated
Yeah.
piece of equipment to specific customers, and it's
Yeah.
ready for them, and they have a guaranteed lead time and all that. That's an option for them. But as you really scale forward, additive being what it is, you don't want to be sending parts all around the country if you don't have to. The more that you can do in one spot.
Yeah, point of need stuff.
Yeah.
And so we've got to find a way to get post-processing in that mix for point of need.
Absolutely.
And is there a need for expeditionary post-processing?
It's a question that's been asked in the past. I would tend to think it would be a bit challenging to do that.
I would think so too.
I think the depot is probably the right place for a technology like us to exist.
Makes sense.
For the programs that require, right? Certainly we're more than happy to support outsourced processing. We've got multiple facilities. We can definitely look to be a partner in that regard as well.
Well, I do think modernization in general of the organic industrial base remains a challenge.
For sure.
And the training piece notwithstanding, the complexity of what REM surface engineering does is still very much there. And training that to a young soldier who's matriculating out in a few years is also another challenge. But as with everything, at least we have a maintenance battalion. Taking it to, kind of a side view, when you think about the opportunities for you and how you want to scale, what kind of investments are you thinking you want to be making?
So I think for us, scale primarily means internally at least more processing equipment, right?
Okay.
And supporting that outsourced process
more
base.
stuff.
More stuff.
Okay.
And we're happy to do as much of that as industry pulls us for. But to give maybe a juxtaposition, like we didn't start in additive. Like our surface finishing journey has been going on for almost almost 6 decades now. And most of what we do still to this day is traditional components, so gears,
Yes.
bearings, airfoils.
Yes.
Right. And in that portion of our business, probably about 70% of the revenue it's installed basis. It's where we've put the equipment into customers.
Yeah.
Folks like Sikorsky, Bell Helicopter, people like that, and you were able to. There's some complexity to the process for sure, but it's also one that you can lock in a fixed process dynamic, and that allows for easier operation by those OEMs.
Mm-hmm.
I think that's the end state that'll happen for AM. I just don't know what timeline that's going to be.
When you think about investments for you, because you're bootstrapped, right, like a lot of us,
We are.
what's the signal that would prompt you to make an investment? What do you need to see either from, I'm going to say from the Department of War, what would you need to see from them in order to make that investment? Besides orders, is there anything else? I mean, we all want purchase orders. So is there anything else? Is there an R&D thing? Is there anything?
In terms of specific, like sort of infrastructure scaling on our side, it probably does have to be orders ultimately.
Just
Because we've been
orders.
talking about it for so long, and
Yeah.
there's been a lot of I think a lot of good vision, a lot of good ideas.
Sure.
That necessarily hasn't materialized into a whole lot of actual part processing.
Yeah, you're
on
not
the
the
back
only
end.
one who's said that.
So.
And so at America Makes, we're working to understand more deeply the demand signal that would be needed to support you
Yes.
and all of the others in the supply chain. And we think that diversifying the base, having folks who need oil and gas or medical or what have you is really important for you to be diverse, because the Defense Department doesn't appear to be able to support you fully and the kind of growth. And for them to say, Justin, we really need you to continue to exist, but we're not going to buy anything from you for a while. So I'm not sure what the level of mastery needs to look like, but I mean, that's certainly what we're wanting at America Makes, to figure that puzzle out. And I guess finally, I want to make sure that if you have anything new going on, our community knows what REM Surface Engineering is excited about right now. So talk to us.
Sure. So a couple of years ago, we were really excited for some of the support structure removal technology that we developed, right? So
Yes.
looking to basically combine operation steps, right? So if you've got a
Okay.
part that needs a surface finish improvement, right? Maybe you're just trying to get to, again, that kind of as-cast quality, or maybe a little bit better than that. Can we also execute that support structure removal simultaneously, right? So that's something that we did and validated over the past 2.5, 3 years with the Air Force under some SBIR programs that were very helpful. So that's one, but the kind of the newest, I think the most exciting one, is really some of the work we're doing on internal channel applications, right? So non-line
Internal
inside.
channel applications.
Exactly.
Okay, talk to me.
So it's all
Because nobody sees that, do they?
They don't, right? And so, unfortunately, it can, as you said earlier on, it can be kind of forgotten that, hey, there could be some challenges from that granular additive surface. So we first started dabbling in that a couple years back with some work with NASA Marshall on some of their combustion chambers, the cooling channels, and whatnot. Wasn't an area we worked in previously. Typically we'd always been, we could deal with complex shapes, but never anything fully non-line of sight like that. we were fortunate that we had some successes there, and we kind of grew out of that a little bit. But we get a question a lot, which would be, what if my channel's fully blocked? And we kind of sort of grit our teeth a little bit and say, well, that might not be for us, because like we're removing material,
exactly.
Right? So how long does it take us to get
minuscule amounts, but you're still removing it?
Absolutely. And when do you break through that blockage? So we kind of found that as we saw how the industry was moving, and complexity wasn't going down, but people were sort of having to make design choices that maybe weren't what they wanted to try and avoid those situations.
Okay.
So we saw an opportunity there to try and kind of tweak our technology a little bit to be focused entirely on chemical declogging for otherwise, blocked channels. So
that's exciting.
Yeah, it was one of the larger stretches, I would say, that we've ever kind of done in terms of like, hey, we think we have this idea, we don't know if it's going to work, but like let's take a shot with that. And so we did. And as the doctor who did the work on this will tell you, it took a lot of failures before we got there.
Always.
But ultimately, we did get to a point where we were able to develop a technology that was going to be preferentially chemically reactive with the powder as opposed to the walls. You're still going to get a little bit of material removal, but now you're talking about like a manageable amount, not the kind of amount that you're going to actually start damaging and cross-linking channels and whatnot. So that was a very recent development that we were successful with. We deployed a prototype system to do this out to Tinker Air Force Base, and now we're looking to further that to additional alloy classes.
That's really exciting. So I'm sure you're going to help us understand at America Makes how that scales across the supply base.
Absolutely.
But like, I'm really excited to see what continues. And certainly there's multiple space applications.
Absolutely. Space and heat exchangers is I mean, it's a place that we saw, again, it's one of those places where additive makes so much sense because you can combine operation steps, you can make complexity otherwise couldn't make. So how do we actualize that, right? And that's kind of where post-processing folks like ourselves, we help to try and enable those great applications.
Well, Justin, I'm glad that we had this chance to chat because that's a really interesting approach for you and a direction that you guys are taking. I'm excited in a year to see where you are.
Absolutely. Absolutely.
And so thank you for talking to me, and good luck at the show.
Pleasure. Thank you for having me.